Hello, ladies and gentlemen, and welcome back. Welcome back. We're continuing our look at the 2015 Manitoba Math Contest, and we're up to question number 7. ABCD is a rectangle. E is on AB. CE intersects diagonal DB at F. Triangle ADE, which for some reason they don't have connected in their picture, has an area of 50, and EFB has an area of 40. Find the area of triangle ABCD. Find the area of rectangle ABCD. Okay. So let's copy our picture here, and we'll add in the triangle ADE. We have A, B, C, D, and we have B, D, and what was it about E? E is just on AB. Okay. So we have C here, E here, and we intersect at F. Now, in the picture, it looks like those are right angles here. But nothing in the question actually leads us to believe that. Okay, E is just on AB, which is very weird. Very weird. Okay, ADE, let's add that in. And it has area 50. We'll put the 50 inside so I know its area. Now, we want ultimately the area of the rectangle, right? Now, I don't really know any of the lengths. They didn't give me anything. But if I were to call ADH, and this may be the base here, I know that 50 is 1/2 BH. And ultimately, I want H, B, and A, so the area of the rectangle would be something like H, A plus B. So that'd be a plan. If I can just sort of work out HA, I think we'd be all set. I don't think they give me that sort of information. EFB has area 40. Okay. So EFB has area 40. We'll put that in here. So how could I figure out 40? We have a diagonal here, and so if I had some sort of, we can get similar triangles. ADB is similar to, call this guy GFB. So maybe I can get a ratio of H to something? Curious. So I don't know. I'll call this length G. I know that 1/2, and we'll make this a right angle, 1/2 GA is 40. But there doesn't seem to be a way to compare G and H, because I'd like to be able to say, G is 2/5 of H or something, and then that would allow me to get HA. But I can't say anything like that. And they didn't give me any other information, did they? Yeah, ADE has area 50, EFB has area 40. That's it. That's all we've got. Well, actually, supposing, so this BC is also H. So if I were to call this X and this A minus X, I know that, Actually, I'm not going to introduce even more variables. Let's just go based on similar triangles. So ADB is similar to GFB, and EBC is similar to EGF. So two of those have H's. I think I'm onto something. I'm just having trouble working it out. So BC over FG is H over G. And that's the same as AD over FG. Because the two triangles are similar, I can also say that that's the same thing as AB over GB. And this one here is the same thing as EB over EG. And I'm feeling quite lost at this point. So EG and GB both add up to EB. EB plus GB is equal to EB. How does that help me? Well then, EB over EG is just 1 plus GB over EG. And that's the same as AB over GB. No, I don't like what I'm seeing here. And I'm not using this 50 over here either, which is, to say the least, a bit annoying. EB is A. So we've got A over EG, and then A plus B over A minus EG. So A over EG is equal to A plus B over A minus EG. And that's the same thing as H over G. And I can't see anything to do here. Other than, I guess, rearrange this. A is 80 over G. So we've got 80 over G, EG is H over G. Multiplied by G on both sides, H is 80 over EG. Or EG is 80 over H. But that doesn't help me a whole lot because I don't really care for EG times H being equal to 80. I want H times A. But I guess that is some sort of progress. We got G out of there a little bit. And we also have B is 100 over H. So 100 over H plus 80 over G, and then we've got A minus 80 over H maybe I can maybe I can get everything in terms of h and g. So 80 over g plus 100 over h. I feel like I'm definitely doing this wrong. 80 over g minus 80 over h is the same as h over g. Right? Right. Okay. So let's get common denominators. So 80h plus 100g over gh all over 80h minus 80g over gh is equal to, well, actually, the gh's will cancel, and we'll be left with 80h plus 100g over 80h minus 80g. Divide top and bottom by 20, we'll get 4h plus 5g is the same as 4h over 4g is equal to h over g. What else can we do? Well, I suppose I could write 4h minus 4g plus 9g over 4h minus 4g is h. Well, the first bit will become a 1. 1 plus 9g over 4h minus 4g is h over g. I don't think that's really helped me. So we'll go back to the previous line. I'm trying to avoid multiplying everything out because I feel like things won't cancel, but heck, we'll try it. So 4hg plus 5g squared is equal to 4h squared minus 4hg. See, I told you it wasn't going to cancel. So we'll have 4h squared minus 8hg minus 5g squared. Excuse me. And I'm just not seeing where to go with this. Logically, this should somehow factor. I'm just terrible at factoring these sorts of things. I guess it is a quadratic in terms of, hey, what do I want? I want g in terms of h or h in terms of g. Doesn't really matter which. So g is, so we get 4h squared. Actually, is it 4h? I feel like it should be, no, 4 times h. Okay, yep. Yeah. Minus 8gh minus 5g squared. And I really wish that were a plus, but what can you do? Okay, I'm going to treat this as a quadratic in terms of h. So h is 8g plus or minus square root of 64g squared minus 4 5g squared all over 8. Can I divide by, no, I can't divide by 8 everywhere. I can divide by 4 everywhere. So that'll be 2g plus or minus square root of 4g squared. Both those 4's will go away, so minus 5g squared, except it's negative, so it'll be plus. All over 2, so it'll be 2g plus or minus square root of 9g, so 3g, all over 2. So it'll be either 5g over 2 or negative g over 2. So h is 5g over 2. And this will allow me to get the answer. Although I really do feel like I have missed some obvious geometric thing. That's okay, that happens from time to time. I don't always do everything the right way. If I wanted to do everything the right way, I would just look up the solutions and present those to you guys. But I try and show my working, which is not always exact. So, what was it? We wanted... So I know b times h is 100. I want a times h. So, there, rectangles h times b plus a. which is HB plus HA, and that's 100 plus, now, what did I just say the relationship was? H is 5/2 G. And I know GA is 80. So this is 100 plus, divide by 2, you get 40. 40 times 5 is 200. So we should get a final answer of 300 for the whole shape. And I genuinely can't think of a better way to do this one, but there it is. I mean, it wasn't a bad question. It had some geometry. It had some slightly unconventional algebra in that you had that expression. You had to treat it as a solution for h in terms of g. So you just said to yourself, yeah, I know there's an h and g in this quadratic, but we're just going to call it a quadratic in h and go from there. And one of the solutions, the negative g over 2, is obviously ridiculous because they're both lengths. So, yeah, not a terrible question, but again, I feel like I didn't do it the way that was intended or the quick way. Let me know if you had a better way to do it, because I would very much like to hear it. And regardless, I will see you guys in the next video for question 8.